The Workload View feature enables you to break down or classify workloads based on criteria you specify. For example, you can view all the queries submitted by a specific user or to a specific database. Having the capability to drill down on workload characteristics can help you analyze issues related to poor query design, cluster configuration, or suboptimal database design, all of which could be slowing down your cluster. To get started, on the summary page of the Data Warehouse section of the app, choose the time frame you'd like to analyze. The summary page gives you an in-depth view of workloads that ran on your cluster during the specified time frame. A good place to start your analysis can be zeroing in on the slowest queries running on your cluster. This information is in the Outliers region of the page on the upper right. Using the information displayed here, look to see if there is a common theme among the slowest queries. It looks like many of the slowest queries are being run by user A415358. It would be interesting to take a look at all the queries this user is submitting to your cluster. That's where the Workload View feature comes in handy. To use the Workload View feature, click the Workloads menu item on the left. This takes you to the Data Warehouse Workloads page. Looks like several views have already been defined. Click the Define New icon to get started defining a view into user A415358's queries. On the Define Data Warehouse Workload View page, first name your workload view, and then you'll specify the criteria you want to analyze more closely. We want to look at the specific user A415358. Type the username in the text box and it will appear in the drop-down list so that you can locate it easily. Now, because most queries are guaranteed to run in 5 seconds on this particular cluster, we'll specify 5S as the expected SLA for these workloads. And we'll ask Workload XM to warn us when 25% of the query workload misses this SLA. When you're happy, click Preview to view the results of the filtering. And then, if everything looks okay, click Save to save the view and return to the Data Warehouse Workloads page. To analyze the queries of user A415358, click the workload view that you just created in the list on this page. The Workload View Detail page gives you a lot of information about user A415358's queries. In the Trend region in the upper left, you can get a quick view of the total versus failed versus slow queries by count. Hover over the graph to get specifics for particular days. You can see quickly that 155 queries exceeded the specified 5-second SLA. You can view the same summary type of information for statement type as well, by statement type as well. Hover over the graph to get more detail. In fact, you can hover over any graph on the page to get more details. The Suboptimal Queries region is interesting to focus on for these queries. It's in the lower right region of the page. This region shows Impella health checks are being triggered for the queries. Each health check is explained in the reference section of the Workload XM documentation. Right here it shows that 13 of this user's queries are being slowed by insufficient partitioning, which prevents parallel query execution. This condition causes the system to waste resources and time because it is reading rows that aren't required for the operation. The next chunk shows that 34 queries are triggering the slow aggregate health check, which indicates aggregation operations are slower than expected for these queries. Addressing this issue depends on the cause, but if it is being caused by resource conflicts, allocating different resource pools might reduce conflicts. Another possible cause is overly complex group by operations. In this case, the queries could be rewritten to simplify the group by operations. Then, as you move down the graph, you see the next chunk shows almost 40% of the queries are being slowed down by slow clients. This might mean that clients are taking too long to unregister queries. In that case, more appropriate clients should be used for the workload. For example, it might make sense to use an interactive client over ODBC or JDBC. In the last chunk, it shows that another 40% of the queries are being slowed by slow query planning. This health check is triggered when the query planning time exceeds 30% of the overall query execution time. Frequently, this is caused by overly complex queries. To recap, a good way to approach workload analysis with the new Workload View feature is to, number one, choose a time period to analyze in Workload XM. Number two, review the summary page under Data Warehouse and look for anomalies that indicate suboptimal performance or failure. Then, number three, look to see if the queries involved share one of the following criteria: access the same database, involve the same resource pool, involve the same statement types, are executed by the same user, or started executing at the same time. Then you can use these criteria to create a workload view that will give you the insights you need to troubleshoot the issue.